All right, we will continue today with Chapter 2, Section 2.3, Measures of Central Tendency. Now, for this section, one of our biggest objectives that we're going to learn is the mean, median, and mode. So our first objective, how to find the mean, median, mode of a population and a sample. Next, how to find the weighted mean of a data set and how to estimate the sample mean of a grouped data. This one will be quite challenging, but I'll try to go to it pretty slowly. And lastly, how to describe the shape of a distribution as symmetric, uniform, or skewed, and how to compare the mean and median for each. Measures of central tendency. The value that represents a typical or central entry of a dataset. The most common measure of central tendency is the mean, the median, and the mode. So these are different ways to measure some common or central space of data, of information. Mean. Mean can also be referred to as often said to be the average, and this can be found by the sum of all the data entries divided by the number of entries. So for sum, a Greek letter that we'll see for sum a lot is that E sigma, Greek letter sigma. Remember, that just means to add. So when you see this, it's just a shorthand, so we're not writing plus, 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 plus all the time. When you see sigma, it just means to add, and then it's going to say, what are you adding? Sigma notation, so we have that EX adds all of the data entries X. And we have population mean. So we have the sum of all the X values divided by the entries. So sum of all values and we'll be dividing by the number of entries. And this is the Greek letter mu, and that represents a population mean. So we will find the average for two different things, the population and a sample. Sample mean is X bar. So you'll be seeing these throughout the whole statistics course. So remember, this is said to be X bar because of that line it has above. Let's do an example. The weights in pounds for a sample of adults before starting a weight loss study are listed. What is the mean weight of the adults? Okay, well, we're being asked for a sample mean, but it doesn't matter if it's sample or population, the mean formula is the same. We're going to add up all the entries, so we're going to add 274, 235, 223, 268, 290, 285, and 235. Let's use our calculator. We should get 1,810. And then we have to divide by number of entries. How many entries do we have? We have 1, 2, 3, 4, 5, 6, 7 data pieces. So we find the mean weight, divide the sum of the weights by the number of adults in the sample. So we add up all of our data sets and we divide it by how many data entries we have. We have something that's about 258.6. And that is our mean weight for adults. The median. So just like the mean, this is another form of central tendency. The data value that lies in the middle of the data when the data is ordered from smallest to largest. And we measures of the center of an ordered data set by dividing into two equal parts. If the data set has an odd number of entries, the median is in the middle of the data entry. And if it's even, The median is the mean of the two middle data entries. All right, continuing on to slide 10. Find the median of the weight listed in the first example. Okay, so we first have to make the effort to list all these data pieces in order from smallest to largest. All right, so we have 223, 235, 235 again, 268, 274, 285, and 290. Okay, we have 7 pieces, right? So the way to do this is divide it by 2 and 1 more. So because it's odd, I can divide it by your entry minus 1 and then plus 1. So we have 6 divided by 2 gives us 3 plus 1 will be our 4th entry. So 1, 2, 3, it's our 4th one. And we see that if we work our way to the middle, it'll be this middle number where they meet, right? So what I said above is whatever your entry is, so n minus 1 divided by 2, you'll get a number. Whatever that number is, we're going to add 1. And this is if we have an odd number of data entries. There are 7 entries, an odd number. The median is the middle, or 4th data entry. The median weight of adults is 268 pounds. In the previous example of adult weighing 285 pounds, decides not to participate in the study. What is the median weight of the remaining adults? Okay, so here we have 6. So we work our way towards the middle. Well, we're stuck at 2. There is no exact middle. So we're going to go ahead and take the average of these 2. So if you had a long list, this would be your number. If you have an even amount, you're going to take your number, in this case it's 6, and divide it by 2. You're going to take your entry plus 1 more, the next one. So we have our 3rd entry plus our 4th entry. We're going to add them and divide it by 2. We're finding the average of those 2 numbers. So again, you first want to order your data. That wasn't ordered, I made a mistake. And then we want to find the middle 2 numbers. There are 6 entries, an even number. The median is the mean of the 2 middle entries. So we add them and divide them by 2. So our median is 251.5. So again, you want to put them in order from your smallest entry all the way to your largest entry. You want to find the middlemost number. This was slightly different because there isn't one middlemost number, but there's 2. And we see them highlighted in the arrow. We have 2 numbers that are the middle number. So we add those 2 numbers and divide by 2. The median weight of the remaining adults is 251.5 pounds. Mode. This is my favorite. The data entry that occurs with the greatest frequency. If no entry is repeated, the data set has no mode. If 2 entries occur at the same greatest frequency, each entry is a mode. This is said to be bimodal because there's 2 modes. So in general, it is a data entry that occurs with the greatest frequency. So if you see a number that repeats more, the most repeated number, that is the mode. And we can have a tie for the most repeated number. And if so, again, that would be bimodal. So let's do an example of finding the mode. Find the mode of the weights listed in example 1. So we have 223. There's no other 223. We see I have 235s. And is that it? Yeah, that seems to be it. So we can say we have a mode, right? Ordering the data helps because you'll see where they happen at most frequency, right? So we see, boom, we have those that repeat. Rather if it's just some scattered data. The entry of 235 occurs twice. whereas the other data entries occur only once. The mode of the weight is 235 pounds. At a political debate, an example of audience members was asked to name a political party to which they belong. Their responses are shown on the table. What is the mode of responses? So which one occurred most? We see the highest frequency is Democrat. The response occurring with the greatest frequency is Democrat, so the mode is Democrat. In this example, there were more Democrats than people of any other single affiliation. Comparing the mean, median, and mode. All three measures describe a typical entry of a dataset. The average of using the mean. The mean is a reliable measure because it takes into account every dataset. Well, it's reliable in a sense, but we could be led to a false type of average, right? We'll talk about that soon. The disadvantage of using the mean is greatly affected by outliers. The data entry is far removed from other data entries in the data set. An example is if you think of average earning amounts, how much people make in a year. Let's say you live in a typical middle class neighborhood, but in your neighborhood, the CEO of Amazon lives in. Well, he makes billions, right? So he would change the average because one person that makes so much can change the average of everything. And we'll see an example of that. So let's do an example. The table shows the sample ages of students in a class. Find the mean, median, and mode of the ages. Are there any outliers? Which measures of central tendency best describe the typical entry of this data set? All right, so we want to find the median, mean, and mode. So for median and mode, for these, I for sure need to go ahead and take the time to take all these data entries and label them in order. So order them from smallest to largest number. For the mean, I just have to add up all of our numbers. So we're going to add all of our entries and divide them by the number of entries we have. So we have 1, 2, 3, 1, 2, 3, 4, 5, 6. 3 times 6 is 18 plus 2. We have 20. So we have to add them all up and divide by 20. And that does it. Here it shows the work for us. So take the time to practice with your calculator. Where you add them all up and divide by 20, you should get 23.8. Your median, we're going to label them all in order. Because there's an even number of entries, we're going to add the middle two and divide it by 2. And the most common entry is 20. The mean takes every entry into account, but it is influenced by an outlier of 65. So let's take a look. Our most common number is 20. Our middlemost number is 21.5. Okay, they're pretty close, 1.5 off. But our mean is a bit higher. It's 23.8. That's because of that outlier. The median also takes every entry into account and is not affected by an outlier. In this case, the mode exists, but doesn't appear to represent any typical entry. And here you can see this big gap. Sometimes graphical comparisons can help you decide which measures of central tendency best represent the data set. So here we have all of our data, well, most of it in the general sense, and then we have that 165 entry we had. Look at the big gap. So if we were talking about money income, this is typical amount that a family makes in your neighborhood. And then we throw in Jeff Bezos, CEO of Amazon, and throws everything way off, right? In this case, it appears that the median best describes the data set. So be very careful, especially now with all the information data that we're getting for elections or maybe the virus. You're getting all this data. So it's nice that you can see what the numbers are. If they ever say mean or average, be very wary of that information. A median is a better summary sometimes. Weighted mean, the mean of a data set whose entries have a varying weights. The weight mean is given by x bar is equal to the sum of x times w divided by the sum of w, the frequencies. So it doesn't have this, but put a parenthesis between x and w. You first have to multiply the entry and the weight before you can divide it by the sum of the weights. So here it says where w is the weight of each entry x. All right, your grades from last semester are in the table, assuming, right? The grading system assigns points as follows. A is a 4, a B is a 3, C2, D1, F0. Determine your grade point average of the weighted mean. So aside from the graded mean, we have to determine the weight of each class, right? The credit hours. Not all classes are weighted the same. There's 6 unit, 5 unit, there's even 1 unit classes. But the letter grade has a weight assigned. So every time we see a C, we're going to tie in a 2. Every time we see a D, a 1, an A, a 4, a C, a 1, and a B, a 3. Now we're going to see a graph, a chart where it shows them using numbers. So here were our letter grades, and we're changing them to numbers. Here we have our credit hours, and now we're multiplying. 2 times 3 gives us 6. 2 times 4 gives us 8. Now here we have our formula, right? We're going to take the sum of x times w. Here we have x times w. We multiply them, now we're going to add, we get 40. And we're going to add our credit hours, our w. We get 16. So 40 divided by 16, this is what's said to be our weighted mean. So your grade point average was a 2.5. Mean of a frequency distribution approximated by x bar equals sigma x times f over n. So this tells us what n is, the sum of all of our frequencies, right? Where x and f are midpoints and the frequencies of a class respectively. So what this does is, you know how we can put things into charts? So we have our upper and lower class limits. Well, we can find the average of that data entry even if it's not just that raw data. So first we want to find the midpoint of each class. 2, find the sum of all products of the midpoints in the classes, and find the sum of all frequencies. And lastly, find the mean of the frequency distribution. So here is an example we used in the past. I think it was in last section 2.2. The frequency distribution shows the out-of-pocket prescription of medicine expenses in dollars for 30 U.S. adults in a recent year. Use the frequency distribution to estimate the mean expense using the sample mean formula for the mean expense is 285.50. Compare this to the last estimated mean. All right, so it took the time to find that class midpoint. So we added the lower and the upper, and we divided by 2. We had the frequency for each entry, and we take the time to multiply them. 272.5 times 3 gives us 517.5. 208.5 times 2, we get 417. 244.5 times 5, you get 1,222.5. When we add up our data entries, we should get 30 because there's 30 data entries. And we add our multiplication part, where we multiplied x times f. Now, according to our formula, we take our multiplication portion and we divide it by our entries. So we get 287.7. The mean expense is 287.70. This value is an estimate because it's not based on the class because it is based on the class midpoints instead of the original data set. Okay, now we're going to take the time to talk about graphs and the type of distribution that it may have. First, and the one we'll hopefully see most of because this allows us to do a lot of things, is a symmetric distribution. A vertical line can be drawn through the middle of the graph of the distribution, and the resulting halves are approximately mirror image. So this was talking about the half. We see that this half is about the same as this half. And notice that mean, median, and mode lie exactly in the middle. That's an important feature. Next is uniform. All entries or classes in the distribution have equal or approximately equal frequencies. So it's all the same. We have the same mean and the median. It is symmetric. And we can have tails. So the tail of the graph elongates more to the left. So because we have the tail to the left, we say this is skewed left. Now, your mean always follows your tail. So our mean is closer to the left, followed by your median and your mode. And we have skewed left or negatively skewed, so there's also a skewed right. The tail of the graph elongates more to the right. So here we have a longer tail to the right. And like I said, your mean always follows your tail, followed by your median and your mode. The mean is to the right of the mean. The mean is to the right of the median. All right, that's it for this section. If you have any questions, feel free to post them on our discussion board or send an email. Thanks.